Hello guys, welcome back to Life Technologies channel and thank you for watching. Please remember to subscribe to our channel for more tutorials on IPRAN architecture. In our previous series, we've looked at IPRAN architecture in detail, the node that we have from the BTS to the CSGs to the aggregation node to the RSGs and then to the controllers. So before you start deploying services on IPRAN network, you need to ensure there is connectivity or reachability from the BTS to the controllers. So you need to deploy some protocols. This is why in our today's class, we are looking on how to design an IGP. In this case, we are looking at ISIS as our IGP, on how to deploy IGP on our network, how to design it so that you have reachability end-to-end on your IPRAN architecture. So for a service provider, this is normally the architecture of the network where you have the aggregation and the access. So normally the network is in rings, like we have rings, we have nodes connected in a ring setup. This is to improve the network redundancy and availability. So you will have access rings and aggregation rings, and the access rings are normally connected to the aggregation rings. So you need to do proper planning and design for your IGP to be able to achieve the connectivity that is required before you start deploying the services. So in this class, in this tutorial, we are focusing on ISIS as our IGP. You know, we have different protocols that can be used as IGP. You can use OSPF, you can use EIGRP if you have Cisco routers in your network, and you can even use RIP. But we will be focusing on ISIS as our IGP in this tutorial. So what are the key concepts that we need to cover or to pay attention to when we are running ISIS in our network? The first one is ISIS areas and levels. So ISIS, similar to SPF, had the concept of areas. So normally you will have to define your network to divide your network into different areas, and then levels. Which level should you use in ISIS? We have level 1, we have level 2, and we have level 1, 2. So which level should you choose when you are deploying your ISIS network? Then we have the ISIS cost. Remember, IGP decides or select the best path based on cost. So you need proper cost planning in your IPRAN network. Then the network type. Which network type should you use? Then if you are running different processes in access and aggregation, you also need to do route import between the access and aggregation processes. How should you achieve that? Then we have the network entity, which uniquely identifies an ISIS area, the node name, and then we have authentication, IGP, and LDP Sync, and then BFD for IGP. So these are just some key concepts that you need to pay attention to when you are designing your ISIS protocol for your IPRAN network. So let's first start with the ISIS areas and levels. So we know ISIS supports 3 levels. We have level 1, level 1, 2, and level 2. So which levels should you use? It purely depends on the requirements of the customer and also your target network. Many times for an ISP network, we normally use level 2. Like all the entire network will be level 2, which means all the routers are kind of in the backbone network. Remember, ISIS doesn't have the concept of virtual link like the OSPF. So you need to properly design your network such that we have connectivity. We have routes being exchanged throughout the network. So for areas, you have to define your areas, your ISIS, your IPRAN network into different areas. This one will speed the network convergence, because if you have just one area, if there is an update, it means it has to be propagated throughout the entire network. And if you have many routers or a large network with so many routers running SIS, it means it will take time for the convergence to happen. So many times we recommend that you divide your network into small areas, which will speed network convergence. And even when you are troubleshooting and your network is divided into small areas, it's very easy to identify where you could be having an issue. So always divide your network into small areas and then use level 2 for all the networks, such that all the routers are in the backbone area. But this one purely depends on the requirement and the target topology. You can decide to have level 1 and level 1 2 routers and then level 2. So you have a backbone of level 2 routers, and then level 1 2, this one acts like the ABR, will be connecting different areas. So we will have level 1, which are like the internal routers, will be connected to level 2 routers through level 1 2 routers. Then another important concept that we need to look at is the network entity. So network entity is just a special form of network service access point. And for the ISIS adjacency to be established, you need to configure a network entity, and it should be unique in an area or in a routing domain. So when you are configuring a network entity, you need to be very keen so that you don't have duplicates. You don't have router 1 having the same network entity with router 2. It must be unique for the routing domain. So a network entity consists of 3 parts. We have the area ID. So this one is similar to the area in the OSPF, where you have like the area 0, area 1. So you need to define the area ID. And this one is 1 to 13 bytes in length, and it uniquely identifies an area in a routing domain. So you need to have a unique value, and this one will be the area ID. Then you have the system ID. This one is normally 6 bytes in length, and many times we normally use loopback 0 to generate the system ID, because remember, loopback 0 is a unique system IP address. So normally we generate the system ID from the loopback 0. We can discuss about the process of generating the system ID in our next series. The third part of the network entity is the selector, which indicates the type of the protocol. Many times it's 1 byte in length, and many times it's fixed to 0, which means it's IP. So this is the structure of the network entity or the area address. So you have the IDP, DSCP, and then the area address is made up of the AVI, IDI, and then we have the higher order DSCP. Then you have the system ID and the selector. So this is just an overview of the network entity when it comes to ISIS protocol. Then another thing we'll be looking at in depth is ISIS cost. So remember, IGPs determine the best path based on cost, and the shortest cost will be selected as the best route. So you need to do proper planning of cost in your network to ensure that you have the optimal routing. If you have, for example, a low capacity link, then you need to do manual cost configuration to ensure that ISIS doesn't choose these as the best route, because if it uses it and it is a low capacity route, then there will be congestion. So you need to do proper planning of cost in your entire network so that you can achieve optimal routing of traffic. So by default, the link cost value of ISIS interface is 10. So it means if you don't configure any cost, the default value for all the links will be 10. And the cost style is narrow. Remember, ISIS supports 2 types of cost. We have the narrow, which ranges from 0 to 63, and then we have wide. And many times we change the cost style to wide so that we have a big range of the values. Remember, the wide one goes up to around 6 million. So when you are doing cost planning, you have the flexibility of configuring higher cost up to 6 million as compared to the narrow one, which is limited from 0 to 63 only. So how do you configure the ISIS cost? The first way is the interface cost, where you specify the cost on the interface. This is the most used mode, where many times we manually configure the cost on the interface. Then you can also do it globally. Like you configure in the ISIS process, you specify the circuit cost, and then this will be used for all the links within that ISIS process. Then you can also do it automatically, which means it's calculated based on the interface bandwidth. And by default, the cost of each interface will be the bandwidth reference out of the interface bandwidth times the default cost, which is 10. So many times you will find us changing the bandwidth reference, and then the ISIS will be able to generate the costs based on the bandwidth reference that you have specified. So always remember to do a proper planning of the costs to ensure there is optimal routing of traffic in your network. Then another thing that we need to focus on is ISIS IGP to LDP synchronization. Remember, if you are running MPLS in your network and then you are using LDP for label distribution, then we need to have some synchronization between LDP and IGP for the normal operation of the network. So when you are using LDP, you need to ensure that before there is switchover, the two protocols, LDP and IGP, are synchronized. So for the LDP IGP synchronization, this one applies to MPLS networks where we have primary and backup LSPs. So remember, LSPs will be generated based on IGP. So once the IGP is up, we have the LSP being generated. But for traffic forwarding, we need to depend on the labels which are assigned by LDP. So when the LDP session on the primary LSP fails, or the faulty primary LSP is restored, you need to enable synchronization between LDP and IGP to prevent traffic interruption. Because if it doesn't synchronize, then you have traffic switching over to an LSP that doesn't know how to forward the traffic. The LSP is up, but there is no synchronization between the IGP and LDP. So normally you need to enable these IGP to LDP synchronization to ensure that we are not having traffic interruption whenever there is active standby switchover of the LSPs. So how do you enable IGP to LDP synchronization? We have two modes. The first one is interface view, which means you are enabling it on an interface. On an individual interface, you configure the ISIS LDP Sync. As you can see, this is the command you use, and this is how you enable LDP Sync on an interface. And then you also need to configure the hold time, the interval during which traffic is still transmitted along the backup LSP before the session of the primary LSP is re-established. So you configure some hold time cost or timer such that the traffic switchover doesn't happen immediately. It has to wait for some time before the traffic switchover happens. Then another way to configure IGP to LDP synchronization is by configuring it globally on the ISIS process. So you just enter the ISIS process and then you configure ISIS LDP Sync, which means you've enabled it globally in the ISIS process. Many times what I've seen is we normally do it on the interface as opposed to doing it on the ISIS LDP Sync. So these are just some important concepts that you need to put in consideration when you are configuring or when you are setting up your ISIS as the IGP protocol. For the ISIS network type, if I just go back to our original slide, for the ISIS network types, we have two types. We have the broadcast. Remember, ISIS only supports two network types. It's either point-to-point or broadcast. So normally we configure the ISIS network type to point-to-point because ISIS is being established between the two nodes that are adjacent to each other. So normally we configure the network type to be point-to-point, and this is manually on the interface. Then for access aggregation import, as I mentioned earlier, when you are configuring different ISIS process between access and aggregation, then you need to have a mechanism to ensure that the aggregation can be able to communicate with the access, and also the access should be able to communicate with the aggregation. So we need a mechanism to ensure that CSG02 is able to learn the loopback 0 of ASG02. If we don't do any route import, then they will not be able to communicate. And remember, later we'll be configuring BGP using loopback 0. So the two loopback zeros should be able to reach each other. So don't just import the access and aggregation process directly. Always use route policies to control what is imported and what is not imported. And this one can also help to control loops in your network. If you just do it without using route policy, you may end up having loops in your network. Then another important concept is the node ISIS name. So when you are running ISIS in your network, it's a best practice to configure the ISIS name within the ISIS process, as we will see in our lab. This one will help you to identify the peering sessions. It will tell you this is CSG02, this is CSG01. So it's when you are troubleshooting or when you are checking the status, it will be very easy to identify which peering status is for which router. So which one is up, which one is not up. From the ISIS name, you will be able to tell. Then authentication. For security purposes, it's also a best practice to configure ISIS authentication. You can configure it globally, or you can configure it within on each and every interface. But remember, when you are implementing authentication, then you need to ensure that the authentication keys are matching on both ends of the interface, or if you are configuring it globally, then it should be matching also for the for the configuration on each and every router for it to be established. If you mismatch, then the peering will not come up. So it has to be merging on both ends for the peering to come up. Then the final part is BFD for IGP. Remember, BFD, this is bidirectional forwarding detection. It can help us to quickly identify network faults, quickly detect network faults. So it's recommended that you need to enable BFD for ISIS so that it can help in quick detection of faults in your network. So these are just some this is an overview of the key concept that we need to put in consideration when we are setting up ISIS as our IGP on IPRAN network. In our next video, we'll do a lab on all these concepts so that we can be familiar with how to configure ISIS on an IPRAN network. Thank you for watching, and please remember to subscribe to our channel for more videos and content on IPRAN network. Thank you.